Hi, so let's discuss 3D geometry. So this is the last video of geometry. So we'll discuss the formulas of these figures: cuboid, cube, right circular cylinder, right circular cone, sphere and hemisphere in that order. Now, cuboid is a rectangular prism. So as you can see, we all know what is cuboid, with length, breadth and height, right? And here the opposite faces are similar to each other. Like this is the, let's say, left, this is right, this is top, and this is bottom. So left and right faces are same, top and bottom are same, right? And let's say that is back and this is front. Front and back faces are also same. Faces are nothing but, like, you can think of walls of a room. Okay, those are faces. So a cuboid has 8 vertices. What is a vertex? It's the corners. So you can see 4 corners on the top and 4 in the bottom. So there are 8 vertices, 6 faces. We have seen faces are the walls, let's say left, right, top, bottom, front, back. 6 faces. And edges. Edges are these, right? Edges are the lines connecting the vertices. You can see 4 on the top, 4 in the bottom, and 4 vertical. So we have total 12 edges. So these are straightforward: volume of cuboid, length into breadth into height, total surface area. So you can see each rectangle is length into breadth. There are 2 length into breadths. There are 2 breadth into height and 2 height into length. So you add them, you get this. Now what is diagonal? Diagonal is connecting this to the other, the opposite ends of the vertices. How to calculate? If you take this, okay, the diagonal of the bottom rectangle, which is square root of L square plus B square. This is the diagonal of a rectangle, and this forms a right angle with height. And this becomes the diagonal. So diagonal is something like this. If I take, let's say, A, B and C, this is A, B and C with this as L square plus B square and H. And let's say if this is diagonal D and this is perpendicular, I can apply Pythagoras theorem. D square hypotenuse square is H square plus square root of L square plus B square whole square. So we know that square and square root get cancelled. What we get? L square plus B square plus H square, which is D square. So D is square root of this. Again, this is the derivation, not very important. You can by heart, okay, or remember the formulas. The next one is, we'll look at cube. What is cube? Cube is a cuboid with length, breadth and height all are same, okay, which we assume as, let's say, A. But number of vertices, faces and edges will remain the same. Volume is LBH for cuboid, so it becomes A into A into A. 2 into LB plus BH plus HL, all are A's. 2 multiplied by 3A square, which is 6A square. Diagonal is root 3A square, which is root 3 into root 3 of A square, which is root 3. Okay, yeah, just correct this. It is root 3 times A, not 3 root A. Okay. Next, right circular cylinder. So all of us know what is a cylinder. Volume of the cylinder, base area into height. What is the base area? It's circle area, pi r square into height. Curved surface area. Curved surface area is the walls, right? The curvature of wall with the curvature is the curved surface area. Now, this is the length of the curve, right? Which is circumference of that circle, which is 2 pi r. Imagine if I cut cylinder at 1 and expand this. So how will the sheet look like? The sheet will look like this. Okay, the cylinder becomes a sheet with 2 pi r being the, so let's say I have cut here and opened this, so it becomes 2 pi r length or width, and height is the other side. It becomes a rectangle sheet. So the curved surface area is 2 pi r into h. Now what is the total surface area? Total surface area is curved surface area plus these two circles. So 2 pi r h plus 2 times area of circle, 2 times pi r square. Okay, so the area is uniform for the cylinder, right? Area won't change, like area of cross section is the same. Yeah, this you'll need to remember. Volume of cone is 1/3 of volume of cylinder, right? 1/3 pi r square h. What is slant height? Slant height is this length. Okay, as you can see, this is a Pythagoras. So you apply Pythagoras theorem, you get slant height. Curved surface area, pi into r into L. Remember, derivation is not important. Total surface area, I told it's curved surface area plus the circle, pi rl plus pi r square. Then we go to sphere. Sphere again, formula is for volume of the, sorry, this has to be sphere, right? Volume of the sphere, I hope, yeah. Volume of the sphere is 4/3 pi r cube, and total surface area is 4 pi r square. This you will need to remember again. Next is hemisphere. Hemisphere is nothing but half the sphere. So volume of sphere is 4/3. So volume of hemisphere is 2/3. Half of 4/3. Total curved surface area. So for sphere, total surface area is the curved surface area. There is nothing else. But for hemisphere, the curved surface area is half of the sphere. Total is 2 pi r square plus the bottom, which is a circle, pi r square. So it becomes 3 pi r square. So this is 2 pi r square plus pi r square, which is 3 pi r square. So these are just the formulas that you'll need to remember. And I hope the geometry is full of formulas. So I hope you guys make a good note of all of this and by heart as many formulas as possible. So I'll see you guys in the next video. Thank you.